Okay guys, let's move to question 6.5. So the question says determine the equation of the tangent to F drawn parallel to G. So if you can have a look on the graph I've drawn with dotted lines or a dashed line, a straight line which is parallel to the graph of G. So what happens here is that this graph, it touches the graph of G only once at that point where the gradient of this graph is equal to the gradient of that graph. So because this new graph it's supposed to be parallel to that graph, it means they are going to have the same gradient. So that's why I've got that graph drawn in that direction. It's because it has to be parallel to G, which means it also has the same gradient as G. And again, which is most importantly, it touches the graph of G at that point. So for a graph to be tangent to another graph, it has to touch that graph at one point. So normally when you deal with this type of questions, you first find the first derivative and find the coordinates. So a tangent to F, which is parallel to G, M, which is the gradient, is equals to 1. So I'm referring to this graph where I'm indicating that this graph, it's tangent to the graph of F and it's parallel to the graph of G. Therefore, the gradient of this graph, it's 1. Okay, so on your next step, what you do is to derive this equation or this function, which is f of x is equals to x squared minus 2x minus 3. So you find the first derivative of this graph, and the first derivative of this graph is the gradient of this graph of f at any point along this graph. But in this case, we're only going to focus at that point because we've got enough information to proceed in answering the question. So I'll explain shortly. I've actually explained already what happens at that point. Remember, at that point, this is the tangent. And also at that point, we know the gradient is 1. So we'll use that information in order to calculate the coordinates at that point. So the first derivative, I think from the previous equation, I've already indicated exactly how do you derive. So you multiply this 2 by 1, it becomes 2. Then the power is 2, you subtract 1, it becomes 1. And there's an imaginary 1 there, it multiplies that 2. You've got 2, then 1 minus 1 becomes x to the power 0, which is 1. Multiplied by 2, it remains as 2. And when you derive a constant, it just falls away. So that's why you remain with 2x minus 2. So this equation is the equation of the gradient of graph of f at any point along that graph. But in this case, we'll focus at that point. So that means going forward, the information that we'll be using the information from that point. So remember, I've just indicated that at that point we know the gradient is 1. So we equate this to 1. Remember, this represents the gradient. So we equate it to 1 because we know at that point the gradient is 1. And we therefore solve for x. So the x value that we get when calculating using this equation, it's that x value at that point. So that means at the tangent where the gradient is 1, the x value is 3 over 2. So remember, you get to that final answer by moving this to the other side of the equal sign. It becomes 3 divided by 2 deliberately so that it cancels out, and your x it's equals to 3 over 2. So that means at that point is 3 over 2. So on your next step, you simply use the x value at that point to calculate the corresponding y value at that point. So you use this x value and substitute into the original equation. The y value that you get is the corresponding y value where x is 3 over 2. So you just substitute into the original equation and you punch on a calculator. This is the answer that you get. You get minus 15 over 4. So that means at the tangent, this is your coordinate. You've got your x as 3 over 2 and the y value as minus 15 over 4. So that means the coordinates at that point, that's where the x, it's 3 over 2 and y is negative 15 over 4. So remember, this point lies on the graph which is tangent to the graph of f. So you can use these coordinates to then determine the formula of this new graph which is tangent to the graph of f. So if you write the formula for this graph, then you'll be done with the question. So on your final step, you've got your straight line formula as y is equals to mx plus c. So at where the x value is 3 over 2 and the y value is minus 15 over 4, you can then use this formula to calculate the c value. So remember, the c value refers to the y-intercept of the new graph. So that means you need the c value in order to complete the new straight line formula. So you substitute these values into that equation. So you've got your y as minus 15 over 4, which is equals to, we know our gradient is 1, and our x value is 3 over 2. You then move all of this to the other side and you punch on a calculator, you get your c as minus 21 over 4. So on your final step, you just rewrite this formula where you substitute your calculated c. So your y is equals to x minus 21 over 4. So that's how you solve question 6.5. Okay, and the last question, which is 6.6, the question says, for which values of k will f of x, which is equals to x squared minus 2x minus 3, and h of x, which is equals to x plus k, not intersect? So you shouldn't be confused by that k. So the k actually refers to the c value. So in this case, they're asking for which c value will this new graph not intersect with f of x, with f of x. So if you have a look at this straight line, if you shift it upwards, it will intersect with the graph of f. But if you shift it downwards, it will never intersect with the graph of f, because the graph of f, it continues upwards from that point. So that means at where k, remember k refers to that point, which is where this graph cuts the y-axis. So from that point going down, this graph will never touch or intersect with the graph of f of x. So that's why we say at k is less than negative 21 over 4, h of x will never touch or intersect f of x. So it means it's only at that point going up where it can intersect with the graph of f of x. But from this point going down, it will never intersect with the graph of f of x.